Now I want to show you how you can imagine do calculus and counterfactuals and all these causality of Professor Judeo Pearl. You see a typical graph that I use in my software. I've created a specific software for causality and statistical arbitrage. So rules of do calculus are very important because they're essential for future modern statistical arbitrage software. So in order to understand causality, you should imagine and the tools you have to imagine that if theory of foliations in dynamical systems and system theory. So on each leaf of foliation, you make x constant. So you understand you distinguish covariates and that intervention and imagine it by geometry of manifolds. So your goal is just to try to understand those invariant sets, those equivalence classes that is formed by foliations. So from a causal model, we go to a submodel. So we just cut some edges. If we do some intervention on X, we just cut some edges. So external intervention Z hat has the same effect that passive observation Z has. That's the identifiability. That's the thing that blocks our backdoor path from Z to Y. Another example in Forex market, having oil price in the nominal value of ZA doesn't have an effect on the nominal value for spread of Aussie dollar USD, pound USD. So a causal model is identifiable if there are a sequence of transformations each conforming to one. When I say about transformation, I mean those dashed lines that we come from a model, causal model to a causal submodel. And then causal inference by surrogate experiments. Sometimes, for reasons of ethics or cost, we cannot do it, so we create a dummy variable. Fortunately, in Forex and financial markets, there is no reason to do that because there is no cost or something like ethics. And so, py condition on x hat cannot be identified owing to presence of bow pattern because you have found a confounding variable that creates some spurious correlations. So spurious correlations happens because of confounding variables that are enemies of identifiability. So there is a solution. You can discover some blocking variables to destroy confoundedness, blocking all backdoors. You know, I talked about backdoors in the previous lecture. So the path can be represented as a confounding arc. A bow pattern represented U is unobserved and dependent on X. Such an equation does not permit the identification of causal effect because there are some spurious dependencies mediated by U. So why counterfactual calculus is deeper than do calculus? I would say that foliations are equivalent classes for manifolds that make some quantity identifiable in Judeo-Pearl terminology. When you fix some variable do, you may cause some foliations to be destroyed. If you have multiple doers and multiple variables, then fixing do may cause the effect of other variables irrelevant and uncontrollable. That's why considering counterfactual should also be considered to avoid considerations of such cases to be forgotten. So here, z is not the cause of x. So we can simplify it, and so the goal is just find those invariants that are some foliations in geometry of manifold. So if you understand foliations in dynamical systems, you get everything. You can understand why do calculus, why counterfactual is very important. So in other words, on that manifold, on that hyperplane, let's say, on that submanifold, everything is dependent on just the intervention. So our goal is just to create a hat tree to make it identifiable. And if it is identifiable, so it's doable, it's the cause. So in any kind of problem, even if it is financial markets, cryptocurrency, anything, we just need to understand invariances of that dynamical systems and make the causal graph. And it's here the query py condition on x set is identifiable if a set of nodes z lies on a directed path from x to y. Then query is identifiable. Z destroys those confoundedness. Z destroys all backdoors. But in control problem, we have a much bigger problem. We have a set of unobserved variable. We have a set of interventions. You can do lots of interventions. It's like multivariable control in electrical engineering. So Z is a kind of variable that we can find to destroy those spurious correlations, to destroy those backdoors and confoundedness. This is a picture from the book of Y written by Professor Judea Perel.